Hi guys, we are still in IP addressing and subnetting subject. Okay, let's go start to continue the part 3 of full understand IP addressing and subnetting. Okay, if you remember, we talked about this. Okay, we talked about we are an ISP and we have 3 customers, and each of these 3 customers have some computers, some servers that need all of them needs be accessible from the internet. So all of computers and or all of servers need to be have on valid IP address or public IP address. So we need to make subnet. Also, we talked about we should answer these questions: how many customers we have, how many valid IP addresses in the network of each computer we need, and new subnet mask for assignable IPs. We talked about also about this one. Office needs 273 valid IPs. Bank needs 944 valid IP addresses, and Seaport needs 2,793 valid IPs. Well, and also we talked about the key important item for calculating subnet mask is write down subnet mask in binary format. Well, we had 172.172.0.0. This is our IP address. This was our IP address with default subnet mask of class B, that it is the 255.255.0.0. If we write down this subnet mask in binary format in 2 bases format, it will be 16 bits, that value that has value 1, 16 bits values. Okay, 8 is here dot again 8 1 bit dot 0.0. Well, how many we need customers? 3. Okay, in 3 if we need 3 customers, so 2 bits are enough. This is until the black part. This was the default subnet mask, and we need additional 2 bits for contains 3 customers, and these 2 bits let me show you, and these 2 bits can be in 4 state or 4 models: 00, 01, 10, 11. The first I said also the first bit in 8 bits of each octet. The first bit's value is 128. The second is 64, 32, 16, 8, 4, 2, 1. And some of them will be 255. So because we have 2 bits, 2 number 1 bits, if these 2 bits contains 00, the subnet address will be 0. If 01, it will be 64, 10, 128, and if both of them are 1, it will be a value of 192. Stop here for more discussion about. If you remember, I said and talked about the network ID and computer ID or host IDs. I said that the network ID as room number. For example, I said maybe you have room number 1 and 10 computers in room number 1. Room number 1, computer 1, 2, 3, 4 through 10. Maybe you have room number 2 and you have and you can have some 10 computers in room number 2, room number 3 again. Okay, one number as room number and the second numbers as host ID or computer ID in that room. So imagine this and imagine more additional partitioning. What about if we partition the room in in some partitions, in some additional partitions, and make more space in each room. For example, we have room number 1 partition, and we calculated and partitioned that room in 4 separated partition. Room number 1, partition number 1, computer 1, 2, 3, 4, 5 computers in partition 1 of room number 1. We have room number 1, partition 3, and maybe we have 8 computers in partition 3. So in this situation, we have additional separated space that added to the our addressing. This partitioned space in room number, it will be subnet address in IP address subnetting. So therefore, if we want to understand the issue and this concept, before we only had a room number as a network number, which contained a number of computers as host numbers, but now a new division has been added in each room, and we say room number partition, and we say room number, partition number, and then computers inside that partition. We call this newly added division as subnetting. Therefore, without changing any room number, we can put computers in a separated environment without changing the room number, and also they have the same network IDs or they have the same network number. They will not communicate with each other because they are placed in a separated subnets, unless we want to. Okay, this is the whole concept of subnetting. I hope this is useful. Well, so these numbers, these values for these 2 bits are subnet numbers. Subnet network ID 172.172, subnet ID 0, and after that will be host ID. Network ID 172.172, subnet number 64, subnet number 128, and subnet number 192. We need 3 of these. In this situation, we have 4 subnet numbers, but just we need 3 of them. Well, continue. So our subnet numbers that we can assign to our customers will be these ones. 172.172 subnet 0 with subnet mask /18. 218 was this one. 8 number ones 255. Sorry, 8 number ones 255, and 2 number 1 is 192. So the length of subnet mask is 18 bits, 1 bits. Okay, so this is correct. Office with 273 online servers need subnet address 172.172.0. starts that subnet from the 0 number with subnet mask /18. The bank with 944 online servers, its subnet mask will start from 64, and the third customer starts with 228. Before each subnet, this is subnet number is 64. Well, before that will be 63.255. So it is the broadcast address that points to all computers in the previous subnets. These subnets IP address starts with 172.172.0.1, starts from this until and continue to 172.172. One before the next subnet is 63.255, because .255 points to all computers that contained and included in subnet 0. So it is not assignable to computer number. Just one address, 172.172.63.255 is not assignable. As well, the next or the second subnet starts from 172.172.64.1, and the and the next its next subnet address is because it's 172.172.128.0. One value before this is 170 or 127.255. Also, it is not assignable because it points into all computers or broadcast address for subnet 64. Step 5. Counting IP addresses assigning to hosts in each subnet. Office addresses. The first office address, a valid IP address that accessible from the internet. Keep in mind, in all solution, it's not need to any change to perform any change in NetID. NetID in all customers you can see stay the same. Okay, the first office IP address that we can assign to computers is 172.172.01 until 172.172.1 before the next subnet. The next subnet we saw is 64. So one before that is 63.255 because 255 is points to all computers in this subnet. It is not assignable. That's IP address assignable is this with subnet mask 255, 192.0. The next customer IP addresses will be 172.172.64.1 and assignable until to 1 before the next subnet. Next subnet is 128. One before that is 127.255 that points to all computers in this subnet. It is not assignable. So the last IP assignable for bank address is 127.254 with this subnet mask as well. And the next customer is Seaport. It starts valid IP address assignable from 172.128.1 until 172.172.191.254. All addresses and customers have same NetID but separated with subnets. I hope you have understood the issue well. All subnetting was this very simple. Now let's first practice this addressing mechanism in practice, in practical mode, and then solve some subnetting questions together. Well, this is the lab time. Well, dear friends, this is the Cisco packet tracer I did run. We need some switch 2960 model, switch layer 2, some computers, some PCs, for example 2 PC in subnet 1, 2 PC in subnet 2, and 2 PCs are in subnet 3. And label subnet 1 172.172.0.0/18. The next subnet is 172.172.64.0/18, and the third subnet address 172.172.128.0/18. Well, so connect these computers to the switch. The first 2 computers connected for port 1 and 2. Subnet 2 connected 3 and 4. Okay, from fast Ethernet to one of switch ports. Okay, and the next 5 and 6. Select connection and connects PC and switch together. Well, we need addressing. We talked about this, okay? 172.172.0.1 to 63. If we address two computers in this range, that two computers should be placed in the same subnet mask. Well, the addressing is here, IP communication or configuration 172.172.0.1 255.255.192.0. And the next one is here 172.172.0.2 255.255.192.0. The next subnet is this one 172.172.64. Well, let's configure the IP addresses 172.172.172.64.1. All subnet masks are same because all have 18 1 bits in subnet mask. 64.1, this is 64.2, 172.172.64.2, and 255.255.192.0. Well, and the third subnet starts with 128. 172.172.128.1, subnet mask 18, 1 bits, 192.0. And the last PC is configured as 172.172.128.2. Sorry, 172.172.128.2 with its subnet mask. Well, let me check why this is not connected. Let me connect that one again. PC from fast Ethernet to number 2. It starts from here until it's up the port. 128 1 and 2. What's this? 128 1. I can ping 172.172.128 2. This is the first time I ping. Maybe the first packet request timed out. One 128.2 subnet mask. Let me check. And this one, oh, this was 72 typed. 72. Sorry. I did a troubleshoot. Okay, that's good, and ping successfully. And these two computers in subnet 2, that starts with 64. What's IPI 172.172.64? Well, I start ping 172.172.64.2. That's okay, and so on. This starts with 0. Ping 172.172.0.2. But these are in the same subnet mask. This is the same. These two computers are placed in same subnet mask, and this one same and okay for last subnet. These we have 3 subnets. Okay. These computers in each subnet, okay, not any problem for communicating with each other, but they will have problem to communicate with another subnets. Let's check. This is 172.172 starts. For example, this one 64. It is not be accessible from the other subnets or from this subnet to the another. Okay, I start ping for 172.128.2. From 64.2 I will send the ping request to the 128.2. Ping 172.172.128. It is not accessible because their subnet numbers are different. This subnet number is 64 and this subnet number is 128 and this subnet number is 0. This is the way we can solve that issue and solve that paradox that we need. Keep network numbers as same, but we need also separated computer traffics or network traffics from each other beside the same network ID numbers. We will learn later in the next videos if we want to communicate between these different subnet numbers. We can use routers to make communication between the different net IDs or different subnet numbers, and I will completely describe you in some later videos. Okay guys, let's go to solve some questions about subnetting. Well, for example, from this page I will solve these two questions. What's about this? Which valid IP addresses is in the same network as 192.168.32.61? I said it's the first step for solve the subnetting questions by typing your subnet mask in binary value. Notepad. Let's go this. Okay. Once the subnet mask bit number 1 bit addresses is 26.12468.22468.2468 until here is 24 number 1 bits. This is a 26, so we need another 246. Okay, 255, 255, 255, 255. This is 192. Okay, this is the subnet mask for class C because it starts from 192 subnet ports. So we have 00, 01, 10, and 11. Okay, four models that 4 situations that can be imagined for these 2 bits. 00 equals to 0 in decimal mode equals 64 equals 128, like our example in slides we discussed about, and 192. Okay, the IP addresses between 0 until the next subnet is 64. One before that is broadcast address, and one before that is valid 62. The IP address starts from 60. The 64 is subnet address 65 until 127 is broadcast 126. This is starts from 129 until 192 is subnet mask, is subnet address, 191 is broadcast, and 190. And valid IPs for this subnet can be 193 until 254. Look at the answers. 59 places in this range. This is okay. Answer A is okay. 63 is not assignable because it will be the broadcast. 63 is broadcast for this subnet. and 127 is broadcast for this subnet, and 191 broadcast this one, and 255 is broadcast for this. So answer A is correct. Answer B, 63 is broadcast. It is not assignable. 64 is the subnet address, and 72 placed in the second subnet. So this is okay. Answer A and answer C, answer D, A and D is answer A and answer D are corrected answers. Another question that says you are setting up a network in which you need 15 subnetworks. You have been given a network address of 153.20.0.0. This is class B address. So the default subnet mask is 255.255.0.0. And you need to maximize, look at this word, and you need to maximize the number of hosts in each network. Which subnet mask will you use? Okay, this is the default subnet mask of class B. It's okay. Well, what question says? It says you need 15 subnetworks based on maximize the number of hosts in each network. If we want 15 subnetwork or subnet, how many bits we need to cover the 15? We need 4 bits. 1, 2, 3, 4. 1, 2, 3, 4 dot 1, 2, 3, 4, 1, 2, 3, 4. The new subnet mask will 255, 128 plus 64 plus 16 plus 8 is 240.0. The subnet mask which we need for assigning 15 subnets or exclude from that 15 subnetworks based on maximum host is here. Yes, we can also use additional bits, for example 1 bits, and it will cover the 15 subnet as well. But the question is emphasized for maximum number of hosts in each network. So these 4 bits are enough, and our subnet mask will be 255.240.0. Well, dear friends, the subnetting discussion ends here. I hope you enjoyed, and feel free to ask any question. I will answer in less than 24 hours. 4 hours. Please comment questions. Good luck, guys, and have a nice time. See you in the next video. Bye.